Okay, so for this section, we are going to look at geometric series. First, the derivation of the formula. So here is the general form for the series, and then we have a couple of notation. One is the Sn. The Sn represents the sum of the n terms in the series, and it is geometric. So notice that we have a for the first term, t1. Okay, AR is you're multiplying a by the common ratio, and then so forth and so on. And the very last term is AR to the n minus 1, which is the general term Tn. Okay, simple as that. Now, what I want to do is that let's multiply both sides of this equation. That's an equation. On one left-hand side is Sn, on the right-hand side is the expanded form of the series. We're going to multiply that by the common ratio R. So let's do that. So R times Sn, and then we'll do the same thing because we have to multiply to the other side. We multiply R by every single term in this series. Notice that when you multiply R into the bracket each term, one term at a time, that's what you will end up getting. Okay, so you get R. So this is our second. So let's call the first equation the very first one. Okay, number 1, and equation number 2 is right there. So what we want to do now, we want to have the equation number 2 minus equation number 1. That means we want to take away the first equation from the second equation. Okay, simple as that. Excellent. I rewrote the first equation. Here it is. Okay, the blue line, number 1. So equation 2 minus equation 1, and notice what will happen. Every single term cancels out. Okay, so remember that number 2, equation number 2 minus number 1, so AR minus AR is 0, AR squared minus AR squared 0, and so forth and so on, all the way to the end. And the only two terms that will that is left behind is ARN and A. Now it is a subtraction, so let's write this as, so what we have is RSN minus Sn equals, now this would be minus A and then plus AR to the n, because we are subtracting. Very good. So now let's simplify more. Let's factor Sn out from the first, so from the left hand side of the equation, we get R minus 1, and on the right hand side we're going to factor A out, and then the way we write it as, you can rewrite it in any way you want, but it make it easier to write it from the positive leading coefficient first in the bracket. Excellent. We're solving for Sn. What are we going to do next? The next thing we got to do, we divide both sides by R minus 1, and sure enough, what you will end up getting is, so you will end up getting A times R to the n minus 1 divided by R minus 1. Okay, there is another variation of this you can actually use. Another variation of that is A 1 minus R to the n, but then the denominator should also be 1 minus R as well. Okay, so both variations are okay to use, whichever you like. So this is the general, basically the formula for the sum of the n term of a geometric sequence. And remember, A is the first term, and R is the common ratio, and n is the term number, whichever the term number is. Okay, so now let's look at a couple of examples. So we want to find the sum of the first 7 terms in this geometric series. All right, now we have all the information that we need to have. A is 12, R is half. So notice what is happening here. From 12 to 6, you have to multiply that by half. That's your common ratio, and n is 7. So let's plug numbers in to the formula. So what do we get? We get 12 is the first term, R is half to the power of 7 minus 1, all of that divided by 1/2 minus 1. Okay, and then from this point on, you just have to take out your calculator, making sure that you're following BETMAS. You got to deal with the 1/2 to the 7th first, and then subtract away, and then go through it and then come up with the answer. And when you do that, you get 23.8125. Okay, simple as that. That's the sum of the first 7 terms of this geometric series. All right, let's look at another example. How many generations must a person go back to have at least 1,000 ancestors? Okay, so that's the total number of basically parents, grandparents, great-great-parents all together. So that creates a geometric series where we want to have in total, when you add them, the sum in here, sum of the n terms, we don't know what n is, that's the number of generations, so that's the n you want to look for, that will come up with would be 1,000. So let's go ahead and write up the formula again. Okay, so when you write the formula for it, this is what you will get. You get 1,000 equals to 2, that's your first term, all right? And your common ratio is 2, so plug numbers in, and then you solve for n. Now, in this case, you have to use logs. So here it is. To solve this, basically what you will do is you will go through, divide both sides by 2, okay, and then you get 500 equals to 2 to the n. This should say 2 to the n minus 1, and then you add 1 to both sides. You get 501 equal to 2 to the n. And then you have to use the log laws. You take the log of both sides, and then when you get n equal to log of 501 divided by log of 2, the answer that you will get is 8.97, but you know, you're going to round it up, so 9 generations. You need to have 9 generations going back to get 1,000 ancestors. So this is the value of n. Okay, simple as that.